Hi. Okay, yeah. So we have 4 presentations today, and one is Margaret's presentation about summary of 5G. We have also my presentation about the joint work that we are doing in 5G. I mean, for the technical report for ITOT Study Group 12, and then we have 2 technology presentations or more specific items, one from myself as well, and another one from Werner. If basically, if anyone agrees, in particular, if Werner doesn't mind, I would keep more or less this order. I mean, I think it'd be useful to if you are also agree with that, Margaret, to start with your 5G general presentation, and maybe later go, I don't know, probably to the joint work, or maybe later to the individual technology presentations and leave the joint work to the end. That might lead to a bit wider discussion, probably. That would be my guess. Yeah, Werner, can we, do you have any particular?
Yeah, so I have a time constraint that I noted in the presentation overview, so I have to leave in about 45 minutes. So
okay, then we'll do it a completely different way. Then we'll start with your presentation, and then we will move differently. So no problem with that. So yeah, the floor is yours then. Yeah, of course, no problem.
Yeah, thank you for being so accommodating. I mean, I'm not a regular participant of these topics, but I will try to follow the remainder as far as I can. So let me share a presentation. So yeah, as mentioned, we're not usually participants of this activity, but I thought this could be interesting for some of you. So this is the output of a small research project that we did together with Deutsche Telekom and ImmersiveCast, which is a provider of virtual reality cloud gaming solutions. And we thought about how could we message KPIs that would be relevant for estimating QE for virtual reality gaming over 5G networks. So it's very specific, but yeah, you'll see. So the idea is you have a situation where obviously ISPs and network equipment operators want to keep quality of experience high. And this applies in particular to novel applications like cloud gaming that are, have specific requirements on latency, where you don't know what kind of network is needed to really be able to provide a good QE for customers. And so the question is, how do you measure the quality of that from the client or server side? But also, how do you measure that from in between? So it's very easy if you're the provider of such a game, if you're sitting on the server or the client, to monitor application-specific information, which you can gather in the software. But the question is, how do peers that simply route the traffic know more about the performance and quality? Because normally all that traffic is encrypted. And so in this project, we implemented a UDP-based message for gaming-related KPIs that we could use to evaluate QoS and also QE to some extent. So here's a very rough drawing that I threw together. Basically, on the left-hand side, you have a gaming server somewhere. In the middle, you have some routing going on through public internet. And on the right-hand side, you have the client device, which sits behind the router normally. Or it could be, the built-in mobile device. So obviously, this is not limited to 5G, but it's also a solution that works on good old fixed-line networks. And in the middle, you have a monitoring device. So imagine you're an internet service provider and you want to know what is the quality of such streams as they are being transmitted over the network. And our idea was to accomplish this by specifically sending messages relating to that. So these messages are sent out of band over the wide area network. So they're not part of the actual gaming traffic, but they're extra messages from the client to the server or the other way around. And they're specifically aimed and crafted for other parties to monitor the service quality. But they can also be used inside the application, which was partly done in that project. And obviously, what can you do with these messages? Well, you could try to make decisions on shaping your network to prioritize certain packets, to generally know how well would such a service even work for your users, for example, with information on the latency, which is a very critical factor in cloud gaming. And this data format is a very simple JSON-like key value object that we embed in a UDP message. And there's a draft which includes more descriptions on the purpose and example results. And I will briefly present that as well. I just need to find the right window. There it is. So you are welcome to comment on this document and to provide edits. This is still a very early draft, and we would appreciate your input on whether this is useful or if you have any additional thoughts. This is basically the introduction, the network architecture I showed you. I just want to briefly present the data structure so that you know what kind of information is being captured. So this data model has different entries that can be added to a message. Not all of them are required. I mean, sometimes you might not even know some of them, or a provider might not want to share those. Excuse me. And you will see that they are mostly related to audio and video quality and network performance. So the expected parameters are, for example, the video codec, which here is an enumerator of typically used codecs. This can be replaced with more standards conformant strings, which is very similar to the video quality metadata activity we have in Norm. We have information on the codec profile, the used presets for encoding, because in our particular use case, this was a specific encoder, so GPU encoder setup with a specific preset, which obviously makes a huge difference in the expected quality for a certain bitrate that is being transmitted. You have information on the video width and height, the frame rate. And here specifically, we want to differentiate between the frame rate that is sent by the server and the frame rate that is actually decoded at the client, because they might differ, because clients might decide to drop frames if their frames arrive at a too late point in time. So instead of buffering, which doesn't make sense for a game, you just drop the frames, and so the actual frame rate goes down, which of course decreases the QE. We also have information on the frame rate, the frame packet losses. Well, either packet losses or frames lost due to lost packets. And then similar parameters related to audio, so audio bitrate, audio codec and profile, etc. In addition, we have a parameter that is the motion to photon latency as estimated by the client. And this is a very important one. So basically it relates to when you move your character in the game, or when you move your hand or just perform some action, what is the latency until you see the actual result of that on your screen again? And this heavily impacts the usability of the game and the overall experience for the user. And this can only be estimated, obviously, by the application itself through round-trip time measurements or specific information from the client and server talking to each other. And then we had additional fields related to video complexity or spatial temporal complexity. This is very generic for now, but we wanted to signal some way, somehow saying whatever is being transmitted, does this require a lot of bitrate or not? So that from an outside perspective, you could, figure out, does this service really need that much bandwidth or not? And finally, we wanted to send timestamps, obviously, for the message, and identifiers for the sessions, which could be anonymized, just to make sure that if you have multiple sources of traffic, you could differentiate between them. And so we implemented this for Android with an actual application, with a 5G network, with a server sitting somewhere else, so we could test this whether it works, and how we or how can we differentiate between, let's say, a 5G network and a standard Wi-Fi connection on a fixed line network using these messages. And so we had a mobile phone running with the VR app and sending these KPIs through that messaging format, which were captured on an intermediate machine with a software that basically just parses these messages. And you can see here, for example, the video bitrate staying more or less constant over a session of several minutes length. And you can also see here how the latency varies. And there it varies quite a lot. So you have like the minimum that we have is 100 milliseconds. This goes up to even 500 to 700 milliseconds, which would clearly impact the user experience. And we've had experts playing the game and noting their experience, and they said it was horrible at these points in time. So that was a basic verification that the messages actually do tell us something about what the user can see. And we also evaluated, for example, the frame rate that was decoded at the client. So this was more or less constant. The reason was that this particular application does not actually drop frames when they're received late, or at least it doesn't signal that in the frame rate. It seemed that the game used actually some kind of TCP transmission for the video stream itself, which I thought was unusual for this type of application because it's very time sensitive, and there's no point in trying to retransmit something that was sent too late or that was lost. But we are in discussions with the developers of the game to iterate on this and to make this more reliable. And finally, we calculated a mean opinion score based on the ITU-TG 1072 model, which is a opinion model for such kind of gaming applications, but it's actually never been validated for virtual reality applications. And we've partly used it outside of its intended scope because the resolutions and frame rates that we were getting were sometimes much higher than what the model has been initially trained on. And so you should see these mean opinion scores not as the absolute ground truth, but rather an indicator of how much the changes of these KPIs could impact the user quality. And then maybe just for your information, that was quite interesting to see. We use these messages to also differentiate between the performance of standard Wi-Fi, a Wi-Fi 6 connection, so basically the latest Wi-Fi standard over DSL, and 5G. And it turns out that actually 5G is significantly worse here compared to the fixed line, which we didn't expect to be that obvious. But it shows that with this chosen messaging, you can, even as an operator, get very reliable information on how the application performs on different types of network. And this also reflects in the mean opinion score distribution. So this is a histogram again. Here just showing the comparison between the 5G and the fixed line network. And with the 5G network exposing quite a few instances in time where the MOS dropped quite low. So I'm gonna stop with this, and would like to hear your thoughts. Maybe you have some related to whether, have you seen similar proposals? Has something like this been implemented? Are there any fields that you think would be missing here? And last but not least, how likely are operators to implement something like this? Or, would this kind of be a problem in terms of user privacy or operators not wanting to share something like this? Thanks for your attention.
Thanks, Werner. So there are some comments and questions, and I will try to. First, we have a lot of feedback, so this is great. So David, first, you're first.
Yeah, thank you. Thank you for the presentation. It's very interesting results. I focused more on the measurement result. I think it was very interesting. But I have two questions about the measurements. The first is about the input lag, or the motion to photon measurement rather. How did you, or how have you envisioned to do the input lag measurements? Because that's usually quite problematic and device dependent, and not to be ignored, I think.
Yeah, so in this particular case, I mean, it was very specific to the application on that device. So that was an Oculus Quest, just walking around, looking around. I don't know actually how the developer of that application implemented it specifically, but I would assume that they take into account everything from sending a control action to actually receiving the results in that MTP number. But obviously, I mean, this has to be verified, and you can only do this if you have the application source code.
Yeah, because I think there are, and this ties sort of to my other question about what decoded frame rate, and I think there's a difference between decoded frame rate and displayed frame rate, and I wonder if it's possible or how to get the displayed frame, because you can have a frame that's being decoded but not being able to, you don't complete the code in time for the, if you have something like the VSync timing, you go past the VSync timing, the old frame gets shown again, and the decoded frame is probably lost or shown in a later stage, which makes sort of displayed frame rate a little bit different than the decoded frame rate.
Okay.
So that can be something to think about how to get, because I think the displayed frame rate is probably what the person sees.
Right, and that could be interpolated from decoded frames. Yeah.
Exactly, and tied to that, especially when talking about VR, you have you can cheat a lot, because in a lot of the headsets you have this time warp feature where you essentially enforce sort of a lag between what is sort of being displayed and what is actually transmitted to you. So you have some cheating done in the headset. So if you move around a little bit, it can time warp and stretch the image a little bit to compensate for your head movements. But the actual content is actually a little bit delayed on what is being displayed. So the motion to photon measurements sort of have two values for VR, or two loops essentially to take into account. One is totally disjunct from the actual rendering and cloud pipeline. It's only local, and the other is sort of the actual rendered content, or how do you see it? But a very interesting area, I think, and there's to have such a set of metrics that could be that can take into account both cloud gaming and VR would be interesting to have, I think.
Yeah, so if you have some information on this time warping stuff, you could send to me. I think that would be nice. Yeah.
Yeah, absolutely.
Thanks.
Thank you, David. Saman, I think it's your turn.
Yeah, sure. Yeah, thank you, Werner. It was excellent work. So to see that how it works. Just one comment from my side is that I think one important information you should also consider that very carefully is the device characteristics, and this virtual reality device. And I know that you tested only one device, but it could be very different from one device to another device. And David also pointed out, like, there could be refresh rate of the device could be very different, but also could be many other characteristics like resolution and all these things. And I think it is rapidly also getting improved over the time. But I think that would be also something interesting. And I guess like you have cloud gaming, you have the opportunity to collect this information much easier than others. And that might be something you can also look into it to add it.
So would there be some parameters that you think would be useful to capture about the device, like not just the type and model of device, but some properties?
I think some properties such as it could be simple things like refresh rate of the. I mean, if you know the model, of course, you can extract those information as well. So it depends on how you want to make such a message format works properly, or reduce the bit that you're spending on that. But generally, I think it takes some time to look into all devices, and not all, but at least the most popular ones, and see what the best way could be to extract them. But I think to me, refresh rate and the the resolution was two important things that could actually play an important role there. But there are many others you might want to look into it, perhaps. Yeah, but excellent work, and I wonder also if such a work can be also extended for cloud gaming itself, and it doesn't need to be only VR cloud gaming. So I wonder.
That's true. Yeah.
Yeah,
absolutely. Yeah.
So it would be very nice also to see that maybe in VQEG. I know that's we are collecting beta stream information, but could be also very similar things that can be built there. So encourage you to also join there to see more.
Yeah.
Yeah. Thanks a lot.
Thank you.
Thanks. There's a comment from Navajit on the chat about the 5G model and the actually how, and maybe I had a question about that, so maybe I take this comment about. So basically, 5G has a lot of variations and so on. So depending on the band that you're using, you might be using the highest capacity of 5G, particularly if you go in millimeter waves, or if you are in mid or low band, you are basically having slightly enhanced LTE from the performance point of view. So it's if you are not working on millimeter wave, it's probably not so surprising that there's this behavior. I actually have a question, because the Oculus Quest themselves, if you have let's say the Android applications of the Oculus Quest, normal way of working, they do not have any 5G modem, so they can only communicate through Wi-Fi. Or are you using this cable-based mode?
Yeah, so in this particular case, it was connected to a 5G capable Android phone with a USB-C cable. Yeah.
Okay. Yeah. So it was okay, because otherwise there might be.
Yeah.
Yeah. But and do you know about the band, or where the test was done, or whether it should be on mid-band or millimeter wave, or well?
So I don't think it was millimeter wave. I would have to get back to you on the details. I mean, there was a specific slice setup just for this test. I think they even tried it, with a box where you put the mobile phone in and where you can simulate everything. But I'm not sure if these tests have been concluded. But I can ask the co-authors. Yeah.
Okay. Yeah. And a small comment, because a couple of years ago I with a request coming from the Nokia customer, and together with some colleague, we built a very, very simple opinion model for VR online gaming. So basically something developed from state of the art and some high-level assumptions, and something extremely simple. We have a small paper on that in Comex 2 years ago that I can send to you. So I don't know, it was something very kind of theoretic, but it could be interesting to see if this applies, if the assumptions are similar, and if they might provide similar or totally different most values, for instance, on your work, to see how different assumptions on the quality might lead to different results.
Yeah, I think I would note that for the G1072 model, the effective latency is probably too low. I mean, for this kind of application, it's even more critical. At least that was noted from the expert testing, where the game was really unplayable, but the MOS was still, better than 3. Right. So that is. I mean, there's certainly a big absolute shift for this particular opinion model. But yeah, I would be happy to see yours. Yeah.
Okay. Thanks, Margaret. sorry for stealing part of your slot, but it's yours now.
No problems. So I just wanted to comment that 5G technology is still maturing and is changing rapidly. And I would expect your results might easily change or change significantly over the next 5 years.
Yeah, I should probably say that these were just excerpts from a pre-test, and I hope that there will be more tests like this, but that was surely not exhaustive, so and surely not representative, where we could say, like absolutely say, this is better than that. So it's not a proper study with a lot of factors, but just showing that you can use this kind of messaging to extract like relevant parameters and interpret them. Yeah, but you're right. I mean, this can surely improve. And there's certainly a lot to be done on the application side as well. I mean, this was just one proprietary implementation, and just by doing these tests and talking with the developers and really thinking about QE from a user perspective and how that relates to how the video is being transmitted, made them aware of many more optimization or much more optimization potential, like which technology are you using to actually transmit the frames? What do you do if frames are not being transmitted in time? How do you like conceal errors that are due to the network dropping packets, etc. Yeah.
I agree. The experiment itself is very interesting, as are your comments on the difference between how you'd like the decoder to respond to transmission errors and to network problems compared to cases where, well, the buffering is fine. And you've got a good point. In this case, it's not.
Yep.
And Lucian?
Thank you for a very interesting talk. I will definitely contact you to cooperate. I'm wondering if you implement something on the inside 5G network that is reacting to those packets, or is for now it's like more sending through more or less any network?
So now it's just passive monitoring basically. But the idea was that this would be a command line application that you could just deploy on any machine somewhere in the network, and based on the output you could make decisions on the network. So you could probably run this in a simulator and see what you can do with it. Yeah.
Great, thank you very much. Yeah, super interesting.
Yeah, I have a final comment, Werner, on the interest of that to service providers and so on. My brief opinion is that probably service providers are, network operators would be interested in having this kind of model or this kind of information about the traffic that they handle, but they will also have strong regulatory limitations on what they can do with this information. In summary, to respect net neutrality. So this is, and let's say, and the second view on that is that even when you can do things, and there are situations when operators can react and so on, it's also a matter on standardization, meaning the 5G networks and so on are quite complex, and the quality of service response which is allowed for the network is very limited. The number of tools which are actually available in production are very limited because network has to do a lot of stuff. So there's not there are some things that the network can do to react, and in principle the whole idea of the 5G QoS management is around that, and the possibility to define specific service slices that can do this kind of things and so on. But in practice, well, things are a bit more difficult when they need to be applied at scale. But yeah, in general, I think it's a good. So it's similar to with the metadata information. So I think it's good that we, as the QE community, try to promote this and push this and move this, and maybe in the future we can see a reaction in general from the network configuration and operation community. Mm-hmm. But it's a long way.
Yeah, thanks for your input. So I would really appreciate if you just have a look at the table and just let me know if anything's missing, like what Salman has said. Obviously, the device properties have to be known. That would be really helpful. Yeah. Thanks for.
Okay, I'll continue. Great. If there are no more comments for this presentation, which there don't seem to be, I think that I will go with the other technological presentation, which is mine. So basically, invert the whole order that was tempting, because it has some relationship with this. So I think that it's nice to. It might be interesting to watch them together. I'm trying to find the slides while I talk. And now I need to find the right window to share. Sorry about that. Okay. Okay, not this one. Sorry. Almost. Okay. Okay. So I hope you're seeing my presentation now. Someone can confirm?
Yes.
Okay.
Yes.
So this is about having a kind of a similar problem with a different use case. I've been talked about this a couple of times, involved in a cooperative project involving some cooperative and connected automated mobility. So some, let's say, 5G related car operation in the corridor between Spain and Portugal. And one of the use cases that this project has is the remote driving of a shuttle that goes between both historical cities, which is a self-driving shuttle, an autonomous shuttle. But you can somehow, I mean, if the shuttle stops because it finds an obstacle that it doesn't know how to handle, then a remote driver will take over and basically put the shuttle back into the right path and then release the manual operation and going back to automatic. So this is the use case. And we are working on that and implementing a demo, and have a lot of technical issues regarding the architecture, because it basically means coordinating networks between two different countries, and it has a lot of issues that has not much to do with this VQEG meeting. But the architecture itself means that you have, for instance, a driver in Spain, the car is coming from the Portuguese side and it's connected to a 5G G-Node B. And then there are a couple of edge servers involved that handle the traffic and communicate between them and send the traffic to the driver. So basically, the driver has some cameras. So the vehicle has 4 cameras covering the whole perimeter, and also some telemetry data. And the driver needs to send back the control stream, meaning the steering wheels and the speed commands for that. And of course, we are testing that, but in general, we wanted to be able to see, okay, if we have some traces in the network and if we measure the network in different points, would it be good or bad for driving, which is doing this kind of planning or analysis that Bernard somehow presented for the monitoring case for the gaming. So we have defined 3 different use cases based on the use cases coming from the VQEG working group, meaning, okay, driving at probably high speeds, this is not going to be tested, maneuvering or parking, so driving at relatively low speeds, and supervision. So basically not for the particular case of this vehicle, but for a real vehicle going into the highway, being able to have like a remote co-pilot helping the driver, which might be human in this case. And the thing is that in this situation, the final KPI is simple to describe. I mean, it's possible to drive or to help in the driving, and the maximum speed will depend on of course, on the latency and of the safety distance that you can maneuver. But the scenario is very, very complex. So the thing is, how can we somehow estimate whether the network will provide enough capacity to drive, which is the purpose of an opinion model. So what has been done for this over the last lot of years, particularly when people started designing opinion models in speech quality, is that you have a model which somehow with basically network KPIs and some information about the system configuration is able to predict the average minimum opinion score of the user. And this is, for instance, an example coming from G1070, which is about video telephony, if I recall correctly. And in fact, ITOT has some standardized models, like the one for video telephony, or the one for gaming that has been used in the previous presentation, or the oldest one, which is the one for telephony, for voice transmission, the E model. But there is no standard model for remote driving. So, and of course, you could try to go through the whole cycle of developing one, but it might be too costly. And in principle, when people start thinking about that, they don't have the whole information. Even maybe the system doesn't exist, so you cannot actually do the right test and so on. So you need to somehow make some estimates on how the network is going to behave. And what people normally do in this case is just define hard requirements, meaning, okay, I need, I don't know, 60 megabits per second or 40 megabits per second of bandwidth and a latency which is not higher than 200 milliseconds and so on. But what we want is something which is more continuous, where we can have several factors and we can have an approximate idea on how they will combine together and so on. So what we did for this work and for this paper is building, let's say, so this is a kind of a mental experiment, meaning, okay, with what we know from the state of the art, how would this opinion model look like? And therefore, can we make some preliminary assumptions on whether the network is going to be enough or not? So the idea was trying to simplify existing opinion models to the very basic, because we don't have a lot of information, we cannot have a lot of degrees of freedom. So it goes really, really to the higher, to the order of magnitude things. So basically, we defined the model where we combine the three main components of our problem, which is the video coding quality, the macro rocking, and the delay. We combine it using a simple model, in particular a multiplicative relationship. Okay. There can be additive, like typical opinion models from ITOT. There was some discussion about which is better, but okay, we have a high-level estimate, so they don't behave so differently, to be honest, when applied to the high-level view, which is what we are targeting. And we have also some S-shapes and kind of some logistic function to map a bit this linear into the particularities of the Moses scale, which is kind of compressed to the edge, and then we use this E-model curve, which comes from the old G170 and then 7 recommendation. So we have worked with three high-level components. The first one is video quality, and for that, okay, we have made some assumption based on existing standards about the rate distortion general model. Again, we have used a very simple model, exponential one, trying to gather the most relevant relationship between rate and quality from the network. I mean, from the quality, from the state of the art, let's say. And we also assume that the available video bitrate is going to be at most half of the peak throughput. to account for possible oscillations and so on in the throughput. We have also a model from packet losses. In this case, we have done some. Let's say assume that the main quality indicator has to do with the fraction of the frames which are lost, basically in the first order of magnitude, which is quite related with the number of lost bursts. And in our case, we assume that they mostly will come from cell changes, which is where, for a properly configured 5G network, we are going to have probably the higher number of actual loss rates in the network. And finally, for the delay, there are some different models which relate basically the end-to-end delay or the perceived delay with the quality. We have used this one for telephony. Coming from telephony, there are other models like from the online gaming and so on, but most of them have similar shape. So there's like a range where latency doesn't matter. Then you have like a very quick decrease of the quality, and then you have a long tail. And there are some functional formulations for that, but most of the models have similar behavior. So we picked this one in particular, and we basically assume that the delay comes from the network delay plus the coding delay, which has to do with the number of frames which are delayed in the pipeline plus the time that it takes to transmit a single frame. And with that, we put together all the model, and then we merged them with a lot of throughput databases from the network plus some measurements that we took in that location and in our lab. So this is the color gives you an idea of how things are going to work, but this is the throughput and ping distribution of the different data set that we used. So we are finally able to produce this kind of graphs, which give us an idea of how we think that the network is going to perform in which cases. So basically, in particular, our tests, our preliminary tests. So this is the scenario that we actually want to work on. Our preliminary tests were not so good in that location, but this has improved across the project, fortunately. But the model has allowed us to put this kind of graphics for the network, which is, so let's say it's not particularly validated, but is a way. Of course, I mean, all the numbers are more or less in line with the requirements that come from the different experts and so on. So we try to make sure that the model was consistent, but it's also a way that we can have to have a rough idea of how the network is going to behave and whether the network is going to be good enough or not to handle the scenario that we plan. So this is the presentation and the paper, which is published. I think that the link was in the first slide. So the idea that we made a lot of assumptions, but it's a starting point to basically evaluate the network, and also starting point to actually improve the model based on actual tests that we plan to do with real drivers to evaluate different aspects of the model that we have built. But it's also an exercise that can be done for any use case, which is probably better than just dropping a priori hard limits that are a bit unconnected one from the others. And it also allows us to reach some preliminary conclusions on the networks themselves, which is basically these two are the most relevant, that networks are not optimized for uplink, which is a problem for this kind of use cases. And also that the most limiting factor tends to be the end-to-end latency in the network, because it has a lot of components which are probably not obvious from the very beginning, but do exist at the end, and it might be the reason why why 5G behaved worse than other networks also in the previous presentation. So that's all from my side. And I don't know if there are any feedback or comments. Yeah, Lucian.
No, thank you very much for very interesting presentation. I also very much like that, you know, the model you're presenting is really like a model. Unfortunately, I lost a bit of it because of a network connection I have. So I hope my question is not silly. Yeah, I should go to exactly. Actually, I'm begging to get fiber, optic fiber to my house, but it's not easy in the center of old city. Anyway, so my question is like, you, in my opinion, what Shell also showed, and what I also have seen with my own experience, working with, let's say, people that do a technical task, is that people are amazing in fitting to the conditions. Yeah, like I remember the Shell said that it was really difficult to a professional, this wood unloaders, to make them very sad about the delay. Yeah? And we know that the delay is super annoying if you have to score on the MOS scale, but if you have to do the task and someone tell you, well, this is the delay, yeah, then suddenly you will do the task and probably not with so many problems. So I'm wondering, did you somehow took it into account? Maybe you said so, but I missed it, then sorry for that. And my second question is that with a real driving, when I try to go backward with my back camera, I see that the most annoying, obviously, is not network connection or anything, because there's nothing like that, but really the setup, like you know, the lighting that is going directly into camera. Would you be willing to somehow also take this into account somehow? So like measure the picture quality before even you send it, so then you know that the problems are not from the network, but more from the you know, lighting conditions and how it was recorded.
Yeah. Regarding the delay, we plan to do tests with delay, probably not in that particular environment, because, you know, we cannot risk crashing the car to into the bridge. But we plan to do some delay tests with hopefully with professional drivers and see that we adjusted the delay curves more or less using the recommended delay values from the 5G Automotive Association. So they push like hard values. You need to have a delay and to delay lower than whatever, 200 milliseconds. And then we said, okay, we will map to half of the scale or 10% of the scale. I don't exactly remember. So we didn't, you know, we didn't have any better source of truth than this kind of guidelines that should be refined later. And regarding the capture quality and so on, yeah, I didn't have. So it's a good point. We haven't considered it, but yes, it's a good point that should be considered, because of course also the real human, so your real eye is much better in adapting to bad conditions than the camera. So it's something that we should definitely consider. Yeah, thanks for the suggestion.
Thank you very much.
Okay, so it seems there are no more comments. So I think that we would go with Margaret's presentation about 5G. If you're ready to do that, Margaret.
I am perfectly ready and happy to do it now.
Thank you very much.
Okay, so in addition to my usual video quality research, I have another project that started about a year ago that is looking at 5G, and I've been involved in the 5G meetings we've been holding regularly over the last 6 months, and Pablo asked me to give a general introduction to the 5G technology for everyone in the audience who really doesn't have a clue what's going on underneath 5G. So cell phone communication protocols, The third generation partnership project, which is really just called 3GPP, develops the protocols for cell phones. And they're a combination of 7 standards developing organizations that are listed on the slide that you probably have heard of at least some of, like ADIS and ETSI. And they are long established since 1998, and they send their documents after they've reached agreement in 3GPP to the ITU. So the 3GP protocols, 3G was your flip phone, which enabled voice and text messages. 4G LTE is what we mostly have today. That enabled smartphones, like yours, and enabled both voice, text messaging, and new internet access. So as 5G is deployed, there's certainly opportunities for innovation, and a lot of it is probably going to be around industry use cases more than changing the sort of devices that you have access to. So standalone 5G versus non-standalone 5G. Non-standalone 5G is a 4G network enhanced with support for 5G phones. So this enables enhanced mobile broadband, like higher bandwidth video streaming. But it's not true 5G. The network itself is still a 4G network, and most of what you heard about in 2021 as 5G is really non-standalone 5G. And the sales marketing brochures don't typically tell you that this is the case. So standalone 5G, abbreviated SA, this is pure 5G. So this is rip out the entire network, probably, or at least potentially, no backward compatibility with 4G and 3G devices, which is a problem, of course, for commercial networks. 5G enables 3 areas of services. Enhanced mobile broadband at the top of the triangle, that's very fast bandwidths. Massive machine type communications in the lower left triangle, that's IoT devices, having a lot of little devices. And in the lower right-hand corner, ultra reliable and low latency communications, abbreviated URLLC. Now, from the wireless spectrum perspective, these are conflicting protocols. So you can't just evenly divide your bandwidth between these 3 situations and get the same performance for each scenario as you would at 1/3 of devoting everything, say, to enhanced mobile broadband. So, but 5G has the opportunity for the network to be fine-tuned for whatever is needed, that is optimized for specific user requirements. So the 3GPP components, working from the top of this diagram to the bottom, at the top we have the data network, that's internet, it could be another phone provider. Below that is the 5G core, and I'm not going to go into what the 5G core does, but just know there are very few 5G cores that any company will need. The access network, this is referred to both as the RAN, the radio access network, and a G node B, abbreviated lowercase g, uppercase N B, and I won't go into why those are different. There are more of these, and it divides into the central unit or CU, the distributed unit or DU, and the radio unit, that's your cell tower. So as you go down this stack, you get more and more devices. So we see a lot of radio units, and you can have a single DU providing all of the logistical support for multiple RUs. Likewise, you can have a single CU providing all the support that's needed for multiple DUs. And at the bottom is the air interface going to your user device. So this picture of things is from the 3GPP standpoint. So these are the interfaces most of interest to 3GPP, which are fairly mature and being deployed. And this is the focus of the mobile network operators, or MNOs, who provide end-to-end service for millions of customers. These are oftentimes currently very proprietary and monolithic system deployment situations. So for one large geographic area, the MNO might pick one vendor and deploy their equipment over that entire network. So a relatively new organization is the O-RAN Alliance, established in February 2018. So this is an industry organization where 3GPP was standards developing organization. So the O-RAN Alliance has MNOs, vendors, and academic organizations. And their goal is to extend RAN standards to enable more visible interfaces, more open, more ability to interoperate between different vendor equipments in different smaller pieces. And there are two pieces of particular interest, and that's being able to separate out the radio unit, the cell tower, and the equipment that really needs to be attached to that cell tower to enable new vendors. So as we look at the 5G networks, everything other than that piece of equipment at the cell tower, everything else can be implemented entirely in software. The cell tower, the radio unit, they really need very specific hardware components to enable that over-the-air interface. And so this is an area where there's interest in encouraging more vendors to just go into this one area and make products available. And that interface is relatively mature. The other component of particular interest is the RAN Intelligent Controller, or RIC. And there's actually two of these. There's the near real-time and the non-real-time. The RICs are prioritizing network resources, and it opens the opportunity for things like prioritizing how the network responds if you're exactly at a highway. So you know all of your traffic are moving fairly quickly in cars, rapidly changing between cells. So you're expecting a very different sort of needs in the network than if you're, say, in a warehouse with a lot of IoT devices, or your area has a lot of AR and VR devices that need very low latency and mobile edge computing, as Werner was mentioning. But the O-RAN Alliance, as I said, this is a relatively new organization. And a lot of their interfaces are not as mature as the 3GPP interfaces. So how much faster will 5G be over 4G? So this is an area where it's really hard to get a solid answer because there's so many unknowns. I took a class from Award Solutions where the instructor gave me the numbers that are on the screen here, and he didn't give assumptions for these. So really just treat these as a ballpark maximum theoretical improvement. So for 4G peak download around 3 gigabits per second, it might go in 5G as high as 20. Peak uplink for 4G, 1.5 gigabytes. 5G, it might go as high as 10. But the potential for the largest improvements are if you're at the edge of a cell where you're getting 1 bar from your phone and you're really having a terrible download link and uplink. So downlink less than 1 megabit per second theoretically might go as high as 100 megabits per second. Uplink of maybe less than 100 kilobits per second could theoretically go as high as 50 megabits per second. The actual improvement is probably going to be a great deal lower than the sales hype. So one reason is that a lot of 4G enhancements that have been deployed were originally intended for 5G. So some of the perceived advantage of 5G has already been realized in 4G. And another reason is that the 5G non-standalone networks are very different from the 5G standalone. And what we are seeing deployed today is mostly non-standalone networks. There are some exceptions, but they're relatively rare. And also there's a huge number of unknown factors that are going to impact this actual improvement of what you or your customers get. So what is the spectrum allocation? And this changes from one country to the next and one vendor to the next. What is your propagation environment? How much clutter you have, buildings, trees, rain, snow, etc. What is the network configuration? Are you actually deploying multiple input, multiple output or MIMO antennas? And how good is your software to take advantage of them? To what extent are people virtualizing and deploying softwarization? So the old school network equipment has very specialized hardware throughout the network. And all of the companies are moving to softwarization, which lets them take advantage of operating system improvements, hardware improvements to computers, contemporary practices for developing software. And the impact of those is being realized, and it's an unknown factor. Something as simple as being able to upgrade your hardware regularly underneath the network is going to have an unknown impact, and the CI/CD to continuously get out improvements. I'm told that currently when the MNO goes to deploy a new system, they typically test for a full year before they're confident enough to deploy. So another new opportunity for 5G is the difference between public networks and private 5G networks. So public networks is what I'm using on my smartphone today. So that's a mobile network operator with millions of subscribers, your cell phone, and they have very specific spectrum allocation. As I said, that differs country to country. In the US, the MNOs, I shouldn't say least, they purchase spectrum from the FCC. So the private networks are a new capability of 5G, and it uses all of the same 5G air interface technology, all the same interfaces, all the equipment. But the idea is that this is dedicated to a single organization. So say you have a business in a remote location with very poor coverage, they might purchase and deploy their own private network, 5G network. It could be a manufacturing plant who is wanting to deploy a lot of autonomous vehicles and using a lot of remotely controlled machinery. They might say, we want a network just for ourselves. Hospitals also are another example. They already have a lot of private networks. So there's two main categories of deployment options for private networks. This could either be a dependent network, that is, you go to your MNO and say, I want a private network. I want you to take care of all the details. Or it can be independent network built and deployed by the organization. And there's a lot of options that go from anywhere in between, like part of it, the equipment owned and operated by the company, part owned and operated by the MNO. So the spectrum has a large impact on the effectiveness and the bit rates and so on of these private networks, because that could be owned, it could be leased, it could be subleased from an MNO, it could be unlicensed spectrum. In the US, it could be part of the Civilian Broadband Radio Services, or CBRS. And as somebody was commenting on Werner's presentation, which spectrum you're using has a huge impact. And there's also certainly a possibility with private networks to reduce or eliminate network errors, because you have, if you know you're the only people who have the rights to use the spectrum you're operating in, and it's a private network, so you can choose your network strategies, you can guarantee the response of the network, say, to the automated driving situation that Pablo was just talking about. So there's certainly some opportunities here that are likely to mature and change over, the next 5 to 10 years. Multi-access edge computing, or MEC, and 5G. So MEC is the ability to access cloud-based computing and storage. This is pre-existing. This predates 5G. However, with 5G, there will certainly be nice advantages to take advantage of 5G speed, 5G bandwidth, ultra-low latency with mobile with MEC. So 5G MEC, the computers themselves may be deployed closer to the user's device than was possible in 4G due to some differences in the protocols and configuration of the technology. And MEC between those two factors is likely to enable some interesting new types of devices. So not just smartphones, but other low power consumption devices with very little local computing resources, where the strategy is to have a local camera, stream the video somewhere else, and take advantage of MEC to do analysis, and then either send the results back to your local device or send it to some other location for response. And on the right side, here's some interesting applications I've been hearing about. One is medical training, and there's already augmented reality devices being used for medical training where it's a combination of some physical, say a dummy, and this AR training run on a local computer. But with 5G and MEC replacing that local computer, this would enable more people to take advantage of this medical training. So make it fully automatic. You might have a remote expert watching remotely and giving advice, but say poor areas or rural areas that might not be able to afford these standalone devices could just purchase this AR headset with 5G capability, take advantage of MEC. A similar scenario is first responder training for limited budgets. The same sort of idea to use augmented reality. The MEC replaces your local computers and train on group tactics. So situations where you really need a sudden event to be visible in audio to everyone in the training at the same time so they can all respond. And the MEC and these 5G low latency responses may actually be a better solution, or at least a very appealing solution for the situation. And another example where MEC is appealing is, of course, for manufacturing plants with a lot of automated vehicles. We've been hearing about that just from Pablo and in previous VQEG meetings. So you've got the camera going to a MEC computer vision processing, which may be the private company's MEC, and taking advantage of your LLC 5G wireless connections. So that's everything I have. And are there any questions?
Janet, please.
Sorry, I thought I saw Lucian raising his hand ahead of me. Did I miss something?
I didn't see Lucian's hand. I don't see Lucian's hand raised.
My apologies. And Margaret, my apologies. First of all, because I attended a great part of your presentation by audio only. Just a quick comment more than a question. First of all, thank you. This is very interesting. I just want the group to be also aware of a couple of activities here that are highly related to what you just presented. First of all, there is a dedicated group at Meta called Connectivity, who are basically looking into the overall connectivity problem. And of course, 5G is a major sub-activity in that group. And in particular, they are involved with the ORAN industry group that you mentioned. So I'm quite familiar with how ORAN works. And in particular, I want to make sure people understand that ORAN is far more from operators talking to each other. There is also the concept of making RAN metrics available to end applications and devices, right? So imagine for a moment your streaming application be aware of ahead of time of or in real time of fluctuations that are going to happen in bandwidth and take appropriate action. So a collaborative, essentially, environment where applications and services collaborate with the operators using a standard interface. So one of the major activities of ORAN is very much in optimizing video quality by making sure that radio access network metrics and video related, let's say, QPIs, KPIs are jointly optimized. That's one thing I want to bring up. And there is not myself, but other people in the connectivity organization who are very much involved in this activity. And there are some experiments going on, etc. But I would not like to talk for them, just to make sure that I will bring this information. And if anybody is interested to know more, I'll get them in contact with our connectivity group. The second item, which is basically the one thing that I somehow missed if you presented or talked about it, my apologies, is that 5G represents yet a different angle for optimization and could end up being the most compelling argument from everything else that is being presented, which is the lower, how much lower, I will leave it to the experts to maybe give us figures, but the lower energy per bit required for communication. And the reason why this is becoming extremely important is because there was a recent event hosted by Meta around 5G, and the various groups also active in 3GPP and elsewhere presented. Some of them, by the way, Pablo, came from your group. Nokia Bell Labs presented. And it appears that the bottleneck right now for the wider adoption of a whole number of, in particular, wearable computing devices that can benefit from 5G, for example, like the headsets, the HMDs, is the energy and the power consumption that is required in the back end, right? So having the ability to use much less power, bundled potentially with less power-hungry video codecs, and that's yet another topic which I don't want to hijack, could be the catalyst to make a whole lot of massive deployment of AR, VR, and other applications, wearable, essentially HMDs happen. So in summary, I would say the energy front of 5G is of particular interest to me personally and Meta. And the ORAN activity is also equally important, and I think it can be leveraged to maximize video quality. Thank you.
Okay, thank you, Yanis. I agree. The potential for lower power consumption impacting video is very interesting. And thank you for giving the extra information on the ORAN Alliance. Zafar?
Hi, Margaret. Thanks for a great presentation. And actually, it's quite exciting to see that how we can leverage 5G in industry. So I have just one question. So the range of 5G is less than, for example, 4G. So I am wondering that, for example, if we use it in the ambulance or other such vehicles, so are there any advancements happening to make it more reliable or to extend its range, for example, so that it can be actually used?
So by range, you mean the propagation?
Correct.
Characteristics? Correct. Okay, the propagation characteristics depends on which country you're in and which bandwidth that country is devoting to 5G. So this is not an inherent problem with 5G itself. It's a side effect of choices made by different governments on which bandwidth is used for what purpose. And so there's not much I can really say there.
Okay, so are you saying that 5G can also use the same band which earlier 4G or 3G was using?
Well, again, that's completely a decision based that each country is making of which bandwidth is owned by which users, and therefore what is used for 5G. So the deployment in, I believe it's Rakuten in Japan, and my apologies if I have the name wrong, is I have heard using a particular bandwidth that some people aren't happy with the response of the wireless communication that really is not a constraint of 5G. There are issues like that that will arise just because of choices made of spectrum allocation.
I got it. Thank you.
Thank you. I have, yeah, Navajit says the same, that the actual location is quite country dependent. And I have a comment which is a bit related to that. And if you could go back to the slide about the how fast this is, because there's no magic in 5G. Basically the bits per second that you can get on a radio cell is proportional to the hertz of bandwidth that you have allocated in that cell. I mean, as per Shannon communication theorem. So it's basically, of course, you have a slightly higher bit per hertz in 5G than what you had available in 4G due to higher, being able to achieve higher signal to noise ratio, and particularly being able to exploit it through more dense modulations and more dense MIMO configurations. So you have, you can have spatial and band, so density of the modulation. But at the end of the day, you will get around 5-6 bits per hertz, in that range, 7 maybe, I don't know. It depends, but you can make the number. So basically, the most impacting thing in 5G compared to LTE is that 5G standardized the usage of millimeter wave bands. And millimeter wave bands around 30 gigahertz, 20, it depends on the country, but it goes 26, 28 gigahertz, more or less in that band. And in that band, it's only regulated in a few countries, including US. It's under in the process of being regulated in most of them, but you expect to have around 1 gigahertz of bandwidth to allocate, and this is where you can actually get, this 10 to 20 gigabit per second of bit rate. But this comes at the cost of needing to be very, very close physically to the antenna because of propagation loss. So your coverage range in millimeter wave is a few 100 meter tops, and it decreases dramatically if you don't have line of sight to the antenna, and this is due to propagation. So this is nothing else that you can do. So it's what you expect to have in dense urban dense areas. They do exist in the US, in hotspots like stadiums and so on, and definitely for industrial applications. And this is what you're going to have. But of course, it's going to be at the cost of the range. You can operate in the mid band, in the 2 to 3 gigahertz band, but then the bandwidth allocations, of course, will depend on the country, but it will be much lower. I mean, it will be in the range of 100 megahertz per operator. It could be a bit higher, but there's not so much total bandwidth to allocate anywhere. And then you will have they are the bands which are already allocated for LTE, so you can have similar bands, or you can also share the band between LTE and 5G using some specific techniques. But there you will have similar coverage and slightly higher bit rate, but not much than in LTE. And you can have the low bands, which were also available in 4G, but very, very limited licensing. And licensing is not happening in 5G, meaning 700 megahertz and so on. And in these bands are going to be specifically allocated for rural distribution and so on, so for very large coverage areas, but at the cost of a very small bandwidth. So, for instance, in Spain, they've been allocating just 10 megahertz of bandwidth in that band. So you can expect a longer coverage that you will get from LTE, but not for high bandwidth, high bitrate applications. So this is the kind of trick that you have a lot of different options in 5G, but it's difficult to have all at the same time because there are hard constraints on that. The same happens with energy consumption and so on. So there's a global, better usage of the resources, but it's also a matter of how you can select the resources that you use. That there are more flexibility in 5G than there used to be in LTE. So this is more or less the whole thing. But it's also something that nobody explicitly says when they put this kind of tables in the presentation and so on. And basically it depends a lot on the bandwidth because of of communication limits. I mean, you have this signal to noise ratio, and you cannot achieve higher than 1 plus signal log 2 signal to noise ratio as per Shannon's theorem, and we're quite close to Shannon's theorem because the modulation is very efficient, but we cannot never go beyond that. So this is the whole story, and we were reasonably close in 4G. So and this is the reason, because part of the improvements like MIMO and so on have been backported to 4G. So this is the reason why for the same spectrum type you don't see a lot of improvement. And by the way, this is not going to have to change when going to standalone, because the non-standalone uses the full. So in terms of user plane, it uses the full capabilities of the radio. There's a lot of things of functionality that comes with the standalone, which is basically because non-standalone is 5G radio with a 4G core, but you have the 5G radio. You cannot use a lot of the flexibility and traffic prioritization features that you have in standalone, but you do have all the modulation features that there are in the radio. So it's basically, I believe there might be some tweaks that are not available, but as far as I'm aware, you have at least all the basic features. And in millimeter wave, you can get nice things. I mean, we do have actually in the field, so in field trials, like higher than 3 gigabit per second of downlink, with real equipments and we have issues where the bottleneck is not the radio, but the physical, gigabit interface of the modem or this kind of stuff. So this can happen even with NSA. And yeah, I've been studying a bit of 5G over the last year, but I don't like to. But I think so. Thanks, Margaret, for presentation. I think it was a good overall view, and I hope it's been useful also for the attendance.
Okay, well, thank you, Pablo, and thank you for adding that extra detail where I didn't feel comfortable delving quite so much into the engineering side of things. Yes, so in terms of impact for video quality and our work in VQEG, it means that we're going to observe differences country to country, and we're going to see changes steadily over the next number of years. At least small changes. And so I believe there's no other questions, so Pablo, I'll give it to you for the next presentation.
Okay, thanks, Margaret. So I will go to the last presentation of this session, which is about what we are doing jointly in this work group for as contribution to ITOT Study Group 12, which is this work item GSTR 5G QoE, which is a technical report now named Quality of Experience Requirements for Real-Time Multimedia Services over 5G Networks. So what's this about? So it's a contribution that, okay, we have been talking about this over the last couple of meetings. It was initially proposed as a contribution to an existing work item called GQE 5G. And as we were not proposing any specific recommendation, but mostly describing existing elements, let's say, it was decided to reformat as non-normative technical report, which is this GSTR 5G QoE. And currently, we as group, the VQEG 5G KPI is the only contributor. We had already submitted a first version of this document in this new technical report format to Study Group 12 meeting. It was presented in the last meeting in October. And we have more or less complete draft, meaning covering all that we want to say but not with all the detail that we want to have. And we plan to keep working over the next couple of months to have a final version that we can submit in time to the group so that people can discuss offline, with the hope that in the next meeting of the study group of 12 in June, it will be approved. This is the list of reported authors so far that have contributed to the document, coming from a lot of, or at least a few different companies and universities, as you can see. So what is the rationale? As Margaret says, the 5G brings new opportunities for innovation. And one thing that happens is that for watching video at your mobile device, LTE has probably good enough capabilities, let's say. So, of course, there are a lot of companies and academy and so on, people researching on making best use of this bits per second to give you more nice services to end customers, such as VR or AR things. But it's also important to say that 5G brings opportunities to verticals to build their own networks and their own subsets of the networks with the private or non-public network functionalities that Margaret has just presented. So the idea is that one of the main drivers of 5G is not going to be only the general population, but also these use cases which have specific network requirements for their specific functionality. And if we think about them, they're going to have different quality of experience expectations than the typical end user. So the models that we do have, the standardized models that we do have, might not apply. And in some cases, they're going to have to move existing proprietary solutions or maybe existing wireless solutions to the use case. And then maybe their preliminary expectations about quality of experience might not apply either. So let's think about what we discussed with Lucian 2 presentations ago, that you have remote operators of vehicles, and then if you ask them, they will say that they will not tolerate latency at all, because they are drivers and they don't have latency when they drive. But at the end of the day, they can very, very proficiently adapt to latency, and therefore maybe the quality that the network offers to them is good enough, and they don't know yet. And as there's a lot of different services, there's probably no critical mass in video QA community to develop a joint work and, let's say, a fully standardized method and standard and opinion model and monitoring model for each of the use cases. So we build this document to give you some tools to verticals, so to these practitioners of these use cases that are thinking on deploying and operating their service over 5G networks, to give some tools to dimension the network and to evaluate the actual QoE that they achieve. By providing basically examples and general guidelines to those people. I mean, mostly targeted at the people who want to deploy the network or to use the network, and they need to understand a little the basics on what they can expect, both from networks and from QoE perspective. And it's quite high level, but we hope it's going to be useful for that purpose. So in the scope, we have services based on IP wireless communication, multimedia, mostly video transmission, and with latency requirements. So this is the kind of services that we target. And we also assume that they're verticals. So they're not specifically end users, but probably professional industrial users. And therefore, they will probably have no recommendation devoted to them in terms of quality of experience, but also they might be able to enforce some of the quality of service management properties that the 5G network provides. For them, we will give some common tools to handle the problem, like how to a basic understanding of the 5G quality of service model, a basic idea on how they can map the network KPIs to their quality indicators of the application and some pointers to subjective methods that they can use. And then we will go use case per use case to analyze, describe the main features and the reference architecture to be on the same page. I mean, this is what we are thinking when we describe this use case, so that people can see if it maps to their expectations or not, and some basic ideas of which are the relevant quality indicators that they need to monitor, and how they should evaluate quality of experience. And we have considered these 4 use cases that might cover an important range of applications, and also might inspire or be similar to other use cases which are not covered, but may get inspiration for these 4 properties. So regarding the common tools, we briefly describe the 5E quality of service model. This is a full chapter of the quality of service architecture and a lot of stuff in the 3GPP standards. But this is the basic idea. And this is like somehow gets into more detail of one specific aspect that comes from previous presentation from Margaret. So if you are if you're a service, your 5G network is basically an IP black box that connects your mobile phone with your data network. So basically the location of your service. And there are 3 critical elements. One is the mobile phone. One is the G-Node, so the access network, basically the base station, and the other one is the core. And the specific function of the core handling the user packets is called user plane function. And the traffic here is IP, but it's let's say a private IP. It's a tunneled IP. So your IP packets will go into the 5G network here and will emerge from the 5G network here, and you cannot do anything or intercept them in between. And this is the reason why, if you need low latency, you want this to be as close as possible. And the reason why you would like to put a MEC here, because if in monolithic networks, this might be hundreds of kilometers away from this, and then you will have a lot of latency and problems just due to propagation. But going back to the quality of service models, you can basically define some specific traffic flows here, meaning that you can define packet filters at this and this point and map packets to quality of service flows. So basically based on IP addressing or other stuff. So you can define some filters that say, okay, these packets belong to one particular quality of service flows or one particular service category, and these packets belong to another service category. And this service category have some quality of service policies which you can apply to them. So this is basically what you can do with your packets in the network. Divide packets, assign packets to different flows depending on packet properties like destination, source, ports, and so on, and apply specific quality profiles to each of them. And the profiles are defined by all these elements. So there are 3 types of profile: non-guaranteed bitrate, guaranteed bitrate, and mission critical guaranteed bitrate. For each of them, you can define relative prioritization between one packet from one flow and packets from the other flow, some end-to-end 5G packet delay budget, some allowed packet error rate, and from the guaranteed bitrate, you will have some simple traffic model of the minimum bitrate. So the bitrate which is guaranteed and the maximum bitrate that you allow this flow to happen, and in the case of mission critical, the maximum number of bytes that each burst may have, and the measuring window for the bitrate. So these elements cover the definition of your bitrate guarantee. And in non-guaranteed bitrate, you can have maximum allowed bitrates per session or per user or per slice. So you can top the bitrate that a user can use, and after that start dropping their packets. And there are some standardized combination of these values in red, which are the 5 QIs, which are specifically designed by 3GPP for specific services, and some of them will be picked as reference values for each of the use cases that we are handling. Another tool that we would like to provide, if possible, is knowing, if you know the bitrate, the throughput that your network has, and the packet error rate that you can have in a network, and this kind of network basic measurements, how can you map them to the video quality, for instance? By quality, I'm not saying subjective quality, but basically the video bit rate, or so the video frame rate, and so on, that you can actually expect from the network traces. And to be honest, I don't have any good model for that. This is an exercise that we did in one paper, the one that I talked about, the opinion model for VR gaming, but not something that I would particularly push for that. Good contribution if let's say we're not aware of any standardized model for that. We have some high-level reference that we might use here, but if anyone has like a good idea on pointers that we could suggest for people to read, that would be very, very helpful for us to complete the technical report. And the other tool is a pointer on how to assess the subjective quality, because these vertical users were probably not going to have typical end users, but probably professional end users, and also their use case is going to be active in terms of interactive in most cases, as there is in anyone involving latency. So we've done a first quick overview of potential methodologies that they could use to base their subjective testing on. Basically there are two ideas: design a proper task and perform some measures, and there are some recommendations that go into that arena, like recognition tasks or conversation tasks. There are several recommendations about that, or maybe interactive tasks that can be based on the gaming subjective testing procedure. Also, I noted down the VQEG paper that was presented or mentioned on Monday that we should read to incorporate to that if possible. And we could also use simply normal videos, but representative of the use case, and then going to passive video monitoring that also has been successfully done for some cases in the past. But a bit more on this analysis would be helpful, particularly, more pointers that we could put in the document. We do not want to be extremely exhaustive, but we want to give the reader some tools to check and search for the specific use case. And also, it's important, this classification of the subjects that might be that comes from this voice quality of experience recommendation. But I think it's interesting and something that we might use, which is distinguishing between naive model experience subjects, which is the ones that we probably are going to have in these use cases, the ones that are let's say aware of the use case, but not probably on the technical implications and the technical factors below them, and experts, which are the ones who are aware both from the of the use case and of the implementation. So these few slides were about the standard tools that we are trying to provide to all the use cases, and is the last part of the work that is work in progress. Then we have the 4 use cases. For this, I will be quick because these slides are the same that I presented in July or in June. So we have this teleoperated driving use case similar to the one that I was talking in my other presentation today. We have wireless content production, which is basically, that some of the feature functionality that today is covered by wired equipment or by proprietary technology can be done over 5G, like news gathering. Well, this already happens over 4G, but it might have some implications when moving to the 5G, and also moving the cameras to having wireless cameras using 5G, or even having wireless microphones using 5G on stage. So between the microphone and the loudspeaker or the in-ear monitor, having a 5G network, including the audio processing like the equalization and so on. This one is extremely has a very low bandwidth bit per second requirement, but has extremely demanding latency requirements, probably higher than what 5G is able to provide even today. We have analyzed some of the AR and VR use cases, and we have focused particularly in the ones where we offload part of the computation happening in the AR or VR device to a multi-access edge computing, and then we need very low latency and high bandwidth, high bitrate between both elements, which is a tricky combination. But there's a lot, as we have been mentioning, there's a lot of people interested on that because it pushes the network to the limit, but it can provide a lot of interesting services. And finally, this one was not very involved in the previous meeting. We have worked a bit on that, is the first responder networks. Margaret also mentioned that there are a lot of possible ways where the network can be used by first responders. We have covered two completely different use cases to try to cover as wide as possible. So on the one hand, on-site emergencies, having a connected ambulance to the hospital, and then we need to do a data transmission from the emergency side, and also in motion, and even some feedback from the hospital. And we have a completely different thing, which is infrastructure elements like complete network or CCTV camera monitoring. And then in this case, the problem is having a lot of different devices, how you can make the best use of the global resources of the network. So it's a completely different problem, but in the same area. And this is the summary of the reference KPIs that we cover. I won't go into detail, but as you can see, we have a really wide range. So we have use cases where the throughput requirements are very strong, use cases where it is the latency requirements which are very strong, some combinations of them, and we are only focusing on these KPIs. If we could add more like coverage or error rate and so on, but we simply thought that we didn't have enough information to put meaningful values into that table. So we have, at least for this version of the document, focused into these three. And also we have focused on the summary of the quality of experience factors and the evaluation of the different use cases. An interesting thing is that the basic of the, so like the core of the quality of experience is completely different in one service and others. Like in driving, for instance, is safety, and everything is related to being able to safely drive a car, while you may have other kind of tasks for responders, or having visual quality, but not to deliver, but to be able to have production quality for post processing, and so let's say so as high as possible, because it's going to be degraded down the chain later. So there are different definitions of the QEs and different type of users that need to be considered in each of the use case, and different specific factors of the use case that may apply to the problem. And it's also for us relevant to mention them, because maybe somebody from the automotive industry is not aware that the impact of the quality will depend a lot. The visual quality that you get will depend a lot, not only on the bandwidth, but also on the vehicle speed or on the camera position, because it's not the same to have a camera pointing at front that at the side from the visual compression perspective. So there are a lot of some of these kind of things that need to be taken into account that we have tried to include into the documents. This is the summary of the presentation. So the first version is already submitted. The scope is closed. We don't expect to go wider than the scope that is already achieved, but we want to finish the details by February. Again, the target is provide these guidelines to verticals to design and provide their 5G services with enough quality of experience. We cover these 4 use cases that I've mentioned. And yeah, again, we are still open to contribution, especially in these 2 particular topics of network to application KPIs. So how we can, move from network measurements to not to final quality, but to the application key performance indicator, like the resolution or bitrate of the video, or the end-to-end latency that we can get, and so on. And also on evaluation models and methods for task-based evaluation, specific use cases, particularly for the 4 ones that we have mentioned, or general recommendation for this kind of evaluations. And so if anyone else wants to contribute, just of course, contact me or drop me an email, or join the 5G KPI network, Reflector, or whatever method you want to. And I think that's all. I don't know if there are questions or comments. I see Yanis.
Thank you, Pablo. And I will just repeat the request. And again, I wish I had the information to contribute myself. But in the list that you mentioned earlier, the table that you mentioned earlier, how easy is to add a energy/power figure that can help make the determination? Because for us, not just for us, for a whole number of applications, the energy footprint, or how long will an application run on a mobile device that's using power, is turning to be the most critical figure, right? So the most critical KPI that I've heard from a whole lot of companies is not whether it's going to be 50 or 30 megabits per second, or whether the latency will be 1 or 2 milliseconds, but will it be able to run for 10 hours rather than 2 hours compared to whatever I can achieve today? So any and all information that can be included. I understand your mileage will vary based on what band you are using, what time slicing or other technology, but any figures that can be included, in particular bundled with typical power usage that happens after the reception of bits, which is basically the decoding operation, which is again the other elephant in the room, is that you're going to spend certain amount of bits to on your modem, but then you're going to spend perhaps a disproportional amount of bits to decode those bits, or encode, depending the direction of transmission. So my again, at this point, is a request because I just don't have that data. But if we can extend this report to cover the energy aspect, in my opinion, is going to make it invaluable, at least for a whole lot of applications that I have in mind.
Yeah, thanks for the comment, Yanis. The problem with that, so I see your point, and I think it's good that we can mention this. It's a bit difficult because when we try to put the requirements for all the use cases and so on, it's difficult to get the proper figures that make sense for each use case independently, because we might not have this information, and we have kind of dropped other elements like for instance the reliability of the network for which we have some numbers for one of the use case, but we're not extremely sure about that. So I'm not sure that we can put meaningful figures that we trust, but I think that it could be a good idea to at least mention them and describe that, even if it's for a general technological, let's say, perspective, and even if we cannot break down that into the requirements for each of these use cases, because I'm not sure that they do have that. I don't know if this. So let's say for XR, for instance, is probably people is thinking about that. For automotive, probably people would not care too much about that, because car will consume a lot of power anyway. And the thing is that I don't know if we do have numbers to put. So I don't know if you could, but if you could point me or us to some, if you could provide some pointers that we could check I'll be happy to include them. If not in a use case per use case basis, maybe for some of them where it makes more sense, or as a general thing that okay, we are not covering this use case per use case basis, but this is important, and we can give you an overall idea of how important it is.
Yeah. So just 2 quick comments here, and first of all, thank you again, Pablo. The number one, there are articles, academic, let me call them, / white papers that claim certain joules per bit today. They're making certain assumptions, obviously, that are perhaps over theoretical or over generalized, right? So if one can take these articles and turn them into a little bit more practical, would be the number one request. And clearly, the only use case that I'm referring to are the battery-operated mobile devices here, right? So whether it's a phone, a wearable, glasses, or HMDs, that's obviously where it matters critically, right? But I argue that on the transmission side, it counts, and it matters globally for the CO2 footprint that could or could not come depending on how you view this angle, right? So I think there is a multitude of considerations around 5G that it's better to be at least addressed in this report. And again, in my opinion, it's going to be very important, starting from either theoretical studies that claim that is the efficiency of picojoules or microjoules per bit, right, under different modulation schemes, under different propagation delays and whatever else, both on the antenna, the transmitter, and the receiver, and take it from there. So just a simple table that can be used and referenced will be very, very important. And again, only battery operated devices is what cares, and the applications around it.
Okay. Yeah. If you're available to keep this conversation a bit offline, so that we can give me some pointers and we can discuss it a bit, or point me to relevant people to try to include a bit more of this information into the report, I would be very happy. I'm not an expert on that part, and yeah, in fact, we have considered mostly the things that we were somehow safe. I mean, reasonably sure about, let's say. But yeah, we could probably be a bit more open to add these things to complete the report and make people aware of that, and give them as much information as possible. So thanks, Yanis. Any other comments? It seems not. So this was the last presentation of the 5G KPI session, which I think is the last session for today, but I will give the word back to the chairs to use it at your discretion, of course.
Okay, so thank you. Yes, this was our last topic for the day, and we are roughly half an hour early. So, Shell, are you connected currently? Oh, I see he's not. Sorry, I did not add your last presentation's title to the minutes. Let me do that now, and we can approve the minutes before closing. And Pablo, I did not write anything into the minutes on the 2 talks you just gave. So my apologies for that. Could you write down anything you'd like added to the minutes while we go through the earlier parts of the minutes?
Yes, sure. Can you drop the link into the chat if possible? Because I don't.
Sure.
It'll be easier for me to find.
Sorry, just to add that, in case you want to add anything afterwards, this meeting has been transcribed. So just in case you miss anything, you can see that in the transcription.
Nice, wonderful, thank you. And thank you for that transcription. That's a wonderful luxury.
Sorry, quick question to Margaret. I was wondering, or everyone, I was wondering if we wanted to take a group picture today, or we should leave that to Friday.
It would be better to take a group picture either today or tomorrow. Why don't we take one now and take a picture again tomorrow?
Yeah,
we can do that. Just one quick comment. I noticed the attendance has dropped. So I believe a time, again, we can take two, right? Just to be on the safe side. But I believe a time, I see the peak attendance being close to what here in local time is around 6 to 7 a.m. in California. So I would say, again, if we want to capture most of the attendees, we can probably take another one tomorrow around 6 or 7, you know, or whatever is the local time everywhere.
okay. Thanks for that, Yanis.
I agree with Jenny's idea. I have seen that some people left in the last 15 to 20 minutes.
Here we go. Yes, let's take a picture now before going into the minutes. And so if anybody wants to not wait for approving of the minutes. So if you could, please turn on your cameras. And does anyone know if there's an option to encourage the most possible, the together mode, that's it.
Yeah, the together mode is the best.
My screen is being a little slow responding to together mode. There we go. Okay. Take one in together mode. And thank you, everyone. Kelly. And I'll take one in, after my computer responds, I'll take one in galley mode. Okay, thank you. Go ahead and turn off your cameras. And
Let's save some bandwidth on the internet, right?
Yes. Okay, and I will post those later. Let's see, so. Okay, so here are our draft minutes. So we started with the quality related ITU activities review, presentation on ITU-R activities from Chul-Hee Lee, and presentation on ITU-T activities from Alexander and Chul-Hee. Then Yanis went over the IGVQM database project activities. We moved from there to AVHD, where we had two presentations. The first 209 from Mikawai. And we have links to further information for people to look at. And the second, the discussion on 8K image quality. And then we move to 5G KPI after the break. Starting with Werner's discussion on the proposal for KPI messaging format for gaming QoE over 5G networks. Then Pablo 218, I see some of it is highlighted. Are we wanting a change there?
No, it's the right title. I highlighted it before to copy it, but okay. I don't know if it's me. And we should include here yours, I think.
Oh yes, you're right.
Which is.
I will thank you for noticing that. 221.
Margaret, I thought you had the secret ability to present and take minutes at the same time, but I guess.
Yes. Oddly enough, my note-taking ability just plummets when I'm presenting.
I'm writing it, but I have this anonymous headshot, but I don't know exactly what to add. So
that is perfect. We can just leave it at that.
Yeah, I gave the reference so that in 218, I put the reference of the paper in case anyone wants to get more details onto the presentation. But of course, you can also ask me if you're interested. And I don't know, well, yeah, I don't know if you want to add something about the discussion of 221 or.
I think we should add one issue that came up, that the differences in spectrum allocation per country impact the propagation and responsiveness of 5G devices. That was certainly an issue that that I think is worth our noting. Okay, and Pablo, unless there's any other comments you made you think should be in there.
Well, maybe and also in not also in the propagation and the responsiveness, but also in the throughput that you can get, because throughput is
yeah.
Proportional to bandwidth.
Good point. And we could maybe just note that Pablo provided more details on causes for these differences. No, for the limitations on possible bandwidth improvement. Yanis provided more details on O-RAN Alliance. Perfect, thank you. Okay, are there any other changes before we approve these minutes and close today's session? Yes?
No, not to change, but I tried to, so in the last presentation, I tried to capture Yannis' comments on the importance of energy consumption KPIs, and that we might not be able to do it in a use case basis, but we will try to introduce in the technical report as much as possible.
Highly appreciated. And again, let's take the discussion offline, because I may be able to bring some of our colleagues here who can contribute.
Thank you, Yanis. That will be quite helpful.
Okay, thank you, everyone. And thank you, Pablo, for chairing the session, and everyone else. And we will see you all tomorrow.
Thank you. Bye-bye.
Thank you. Bye-bye.